Welcome to the fourth event in this year's Energy Symposium series, Critical Issues in Energy, hosted by the University of Houston. Today's topic is robotics and automation in the energy industry. I'm Ramanan Krishnamurthy, the Chief Energy Officer here at the University of Houston. We have an amazing panel and moderator, and I'd like to thank everyone for their participation today. I'd like to thank and recognize the President's Energy Advisory Board. The board, constituting about 25 industry experts and leaders, have given UH strategic guidance to advance energy education, research, and outreach. A group that I really like to thank is my colleagues here, my UH faculty colleagues, whom we call Energy Fellows. They contribute to these symposiums, as well as other UH energy programs and events throughout the year, and a real big special thank you to them. A few quick notes about today's event. We are currently live streaming this particular presentation. An archive video of this panel will be available through YouTube in the next few days, and it'll also be available on our webpage. We encourage you to submit your questions for the panel throughout the event through an online link. The link will appear periodically on the screens and can also be found on the right-hand panel on the live stream page. So let me introduce our moderator first here. Dr. Aaron Becker is an associate professor in the Electrical and Computer Engineering Department here at the University of Houston. Aaron's passion, as we'll find out pretty soon, is robotics and control. As an associate professor in the Electrical and Computer Engineering Department at UH, his lab builds robots and trains the next generation of robotics researchers. He's an NSF career recipient. He got that in 2016 and has won several best papers through IEEE and multiple societies. His lab is really one of the coolest labs that I've seen at the university. They manipulate microscale swarms with magnetic fields, navigate robotic tools using medical MRIs. One accomplishment that his lab has is that they can kill mosquitoes with drones. They can search for oil and assemble structures with swarms. He was previously a research fellow with Boston Children's Hospital and Harvard Medical School, where he implemented robotics powered and controlled with magnetic field as an MRI. He did a postdoc at Rice in the multi-robot systems lab, and Aaron's investigated control of distributed systems and nanorobotics with experts in the field. So Aaron got his PhD from the University of Illinois at Urbana-Champaign. And I want to give a special thanks to Aaron for him volunteering to moderate this panel. So with that, Aaron, take it away.
Thank you, Ramanan. So our theme today is robotics and automation in the industry of energy. Now, this is a huge area, and it's growing daily to advances in AI, machine learning, computation, sensors, and power sources. Can you advance the slide? Because maybe you, like me, when you think about associating energy and robotics, you think about a robot with a low battery symbol. Here is Big Hero 6, one of my favorite movies, and he's on his last legs because robots don't function without power. Please advance that. So today we'll dig much deeper into this topic, and we've invited 3 distinguished speakers, and we've asked each to talk about how new advances have disrupted and are disrupting the energy industry. Each has a unique perspective, and they are currently making contributions at different layers in this industry. We've asked each to highlight a current problem and then address how new technology is leading to improvements. Now, I know that many of you listening are students and you earnestly want to have a career in energy, and you would rather not have a robot take your job. So in light of that, we've asked each speaker to explain some of the long-term implications of automation on the workforce. Now, to frame our discussion, I want to review the famous 4 Ds of robotics. You'll notice that none of our speakers has a D in their name, so the 4 Ds are a handy mnemonic, and they help us remember where to use robots. And you advance the slide. So that the energy industry is by reputation and history, a dirty place. Coal is found underground, as are a great deal of our hydrocarbon resources. So using robots in these extreme environments improves the conditions for humans. Next slide shows our NextD, and this shows an image from the Deepwater Horizon oil spill. If only robots had been there instead of humans on this oil platform, then 11 deaths would have been saved. And it's not just deaths. Energy production works with volatile materials, with heavy equipment, with incredible power, and in extreme places. We want robots, not humans, to take these risks for us. Next slide, please. Now, this is a pretty image, and I think that this one here looks almost like an idyllic getaway, doesn't it? You have no commute, no mowing the lawn, no raking the leaves, just surf and sun. We advance one more. Turns out a lot of surf and sun. And so even this best little island, it gets boring. There's a limit how long you can keep a person on an oil rig and maintain their happiness and their productivity. And so what we do is we shuttle people in and out of these platforms, but that gets expensive. And so the goal is to reduce the human presence that's necessary there. If we get to full or partial automation, we could populate this island with machines that never get bored of all of that surf and that sun. Now, our final D on the next slide, it stands for dear. And this isn't your significant other, it's talking about how much it costs. So if deploying a robot results in saving money and reducing delays, then that robot is going to earn its keep. And if a robot can become monetarily dear, then we're going to use that robot for tasks. So as of May 2020, Caterpillar has 276 of these autonomous trucks that are in operation. And they do that not just because they like robots, but they do that because robots are saving them money. Robots have become dear. Next slide, please. Now let me introduce our lineup of rockstar speakers for today. So our first speaker is going to be Mauricio Calva, and he is with Chevron Technology Center. And for 35 years, Mauricio has been working in various aspects of non-destructive evaluation and inspection technologies. This includes field work, lab applications, technology development, and research. For the last 10 years, he has been with Chevron, based right here in Houston, with roles as non-destructive evaluation, level 3 engineer, and as a manager of the research and development program for inspection technology. Now, his work focuses on finding alternatives that give safer, high quality, and efficient solutions. He is exploring integration of advanced cameras and non-destructive evaluation sensors with robotics applicant platforms. And if you see some of his videos, those go all the way from drones to pipe inspection robots, as well as with new systems, probes, applications, and workflows to improve the process of inspection in all areas within the corporation. Mauricio has a degree in physics engineering and a master's degree in materials physics. Next up, we are privileged to have Julie Angus. Julie is the CEO, and she's a co-founder of Open Ocean Robotics. And that's a marine drone company that is transforming how we understand and protect our oceans. She's also a leading adventurer. She's a best-selling author. She's a science and an entrepreneur. And she was awarded the National Geographic's Adventure of the Year Award when she became the first woman to row across the Atlantic Ocean from mainland to mainland. Julie has written 3 books. She's produced several documentaries, and she has a graduate degree in microbiology. She's a serial entrepreneur, and she's also had a successful career in business development and technology transfer. Explore magazine listed her as one of North America's leading adventurers, and Canadian Geographic named her one of Canada's greatest women explorers. Julie is a fellow of the Royal Canadian Geographic Society and the recipient of numerous awards, including the University of Victoria Distinguished Alumni Award and the McMaster University Young Alumni Award. We're going to have our third speaker be John Allen, who is with Allen Energy Consultants. As an industry expert and a consultant to the Subsea Systems Institute, John has contributed his perspective on the varying challenges facing the energy industry and the initiatives proposed by researchers developing solutions to those challenges. John began his career with General Electric Company of England, PLC. That was by founding GEC Oil and Gas and managing the deep water production and underwater remotely operated vehicle business. And that was both in the commercial and the military side. Then John, by acquisition, joined ABB, which you'll recognize as a leading robotics company. And he served as a CEO for ABB's CTech and their Vice President of Technology and Engineering for Oil and Gas Incorporated. He also served as a director of the corporate ABB Oil and Gas Research Center, and that is both in Zurich and Houston, where he coordinated technology across ABB offshore systems, Loomis Energy, Deepwater, and Betco. Now, in what seems to be a pattern, John moved to General Electric again by acquisition and moved into the role of Executive General Manager in GE Energy. There, he was responsible for GE Corporate's business with major oil companies. Now, this included upstream, midstream, downstream, and power generation. John is a graduate of the University of Surrey with a Bachelor of Science in Physics, a Master of Science in Electrical Engineering from the University of London, and a Master of Business Administration from the University of Bath. John is a chartered engineer, and he's a fellow of the Society of Underwater Technology, and he chairs multiple industry initiatives. So please extend a warm welcome to our three speakers today.
Well, thank you very much. You will see on the slides that will be presented are just the collage of multiple views of different areas of our facilities and some of our workers. First of all, I just want to thank the opportunity to talk to you. One of the reasons I just going to present the slides in this way is to try to keep this more as a conversation and share with you our thoughts and what is the direction that we are proposing in this sector to move in the future. Well, first, let me tell you, as it was mentioned before, I'm based in Houston. I work for what is now the Chevron Technology Center. And my job is to find better ways to do inspection. And when we say what is a better way, we normally talk about these three fundamental aspects, which is reducing the risk in general, right, to the equipment, to the people, and to the environment. The second one is to increase the quality of the data and the images we collect. When we do inspection, we use that information to understand what are the condition of the equipment, either when we just manufacture it or after many years of service. The processes that we have in this equipment produces degradation, and those damages may create a risk that may start by a release of a product that may catch fire or pollute the environment and so on and so forth. So the data we collect is of primary importance, and we're going to try to keep it, keep this equipment in the best condition possible. And the third one is trying to increase the efficiency, reducing costs, and improving the way we do work in our facilities. So one of the ways we are trying to accomplish these goals is by looking at better technologies like improving sensors, monitoring the condition of this equipment by using remotely placed devices. And also we're looking at robotics as a way to reach these goals. The way we normally work is we try to make an intersection between a need where we see high value to solve a problem and a technology that it's currently available in the market. If for any reason none of the solutions that are available in the market is capable of solving our problems or not to the level that we need, then we engage in a project where we further develop some of the tools that are already available in the market. If that doesn't work, then we start working with some companies that we ask them to do integration, basically taking pieces and parts of equipment that are already in the market to try to come up with a solution. And if none of that works, then we will engage in a project with a research and development institution, a national lab, or a university. The whole idea is to try to get these solutions to our field as quickly as possible and as much efficient as we can. The faster we can integrate these solutions into our facilities, the more likely we are going to show the value, and then we'll have the opportunity to keep moving into increasing the number of operations we can do with these tools. So for instance, a lot of this equipment you're seeing operates at high temperature. Not necessarily the solutions that are available in the market will operate at those conditions, but certainly we have equipment that operates at ambient temperature. So we will engage those solutions, we will learn from them, and once we have a way to do this work at ambient temperature, we will continue developing these solutions to reach those applications. So not only for inspections, but we are looking at robotics for multiple applications like maintenance, which includes removing coatings and applying paint, doing cleaning and preparing equipment for inspection or other tasks. We are also using robotics for monitoring constructions by having LiDAR cameras mounted on mobile platforms. We are using also robotics for environmental monitoring, so either flying or ground platforms where we have sensors and cameras to try to understand if we are producing an impact on the environment and how to control it. We are also using robotics in security, which includes also response to alarms and in case of an incident, instead of sending a person, a machine goes there to try to understand what are the issues, and then we take action. But of course, my favorite is inspections, right? Because that is where we have a major challenges. In many cases, it's not only the temperature, but this equipment is in remote locations, or it may be in elevated platforms, or it may be just dangerous to have people on those locations. One of the main challenges that we have is to integrate these solutions in our workflows to really accomplish what we call an adoption. The main challenge is that not because there is a technology that is available in the market, we are going to be ready to integrate it in the way we do business. One thing that's important to know is that doesn't matter what we do, we have a solution. The technology or the practices that we use for inspection are not necessarily the safest or the cheapest or the one that provides the best quality, but that's how we do things. So when we come with a new technology, it's not just trying to solve a new problem, but we're trying to replace something we've been doing for many years, change the way we think, change all our processes to integrate new technologies. So the challenge of adoption and getting these technologies to be used as a normal way of doing business is one of the main challenges that we have in our work. Talking about the future, we are seeing how we're going to be removing people from these dangerous locations. And we are already designing offshore platforms where we're going to have them initially minimally occupied by people. This means that we may have a skeleton crew. Then in the next phase, we will have people just coming to these locations every few months. And the goal is to be able to operate these systems with no people present at least for a year, and then further in larger periods of times. So the age of robotics in our industry is just starting. We're seeing merging with other technologies like artificial intelligence for analysis of images and data, and the continued development of this platform as a great way of doing this work. So with that, thank you very much again for the invitation, and I'll let you take the word and go to the next presentation, please.
Hey, Mauricio, thank you so much. I believe, Aaron, our next speaker is Julie, isn't it? Julie, the floor is yours.
Great. Well, thank you so much for inviting me to speak at this symposium. I'm very excited to share my experiences founding Open Ocean Robotics and my thoughts on the use of robotics in the energy sector, and in particular in the offshore energy sector. I don't seem to be able to, oh, there we go. There's my slides. Great. So as Aaron mentioned, I've spent a lot of time on the ocean. I'm very passionate about the ocean, and I spent a lot of time in small boats on the ocean, including spending 5 months rowing across the Atlantic Ocean. And what my time on the ocean has shown me is that it's a challenging place to be. It is, it's a large body of water. It covers 70% of our planet. It's prone to intense storms. And it's very dull too. So, you know, it hits a lot of those dull, dangerous, dirty, dear words that Aaron mentioned. And so robotics can really overcome a lot of the challenges associated with operating on the ocean, making ocean industries safer, more affordable, more sustainable, and even opening the door to new possibilities. So when we look at ocean data collection today, there are a lot of challenges with it. You know, largely it depends on using ships, which can be very expensive. Offshore ships are $25,000 a day or more to run. And you need experienced staff. And of course, you can't go out in all conditions. So by being able to automate data collection using robotics, so these robotics can come in a lot of different ways out on the ocean. It can be a boat like ours, an autonomous boat, which is also called an unmanned surface vehicle or an uncrewed surface vehicle or a remotely operated vehicle, or a robot boat, as my 6-year-old likes to say. There are also underwater assets, so ROVs or submersibles. And these can really add a layer of safety, a layer of affordability, and can improve operations. So for example, with our vessel, which is Data Explorer that you see here, it can go out and collect a range of ocean data, anything from sound with a hydrophone to ocean conditions, things like looking for hydrocarbons, ocean currents, mapping the seafloor, and it it's streamed in real time to a software platform where the operator can control the boat, can see the data, can manipulate the boat to say, go back and get more data. So it provides this level of data analytics and acquisition that may not previously have been possible. And it does that really from the safety of shore. And so in the offshore energy industry, oops, didn't like my moving ahead. Let's try to go back a few slides. There are a number of applications where this vessel can be used. Sorry, could you please go back to, yeah, that's perfect. Offshore energy robotic applications. Okay, let me try that. I think I'm still in control here. So I think there's, a number of areas in the offshore energy sector, both offshore oil and gas and offshore wind, where robotics can play a key role and where in many cases already it is. So there's hydrographic surveying, which is using a piece of equipment called a multi-beam sonar unit that's mounted on the bottom of a boat, and it uses sound to paint a picture of what the seafloor looks like. So this is very important. It's important for determining the depth of the water so that vessels don't run aground. It's important for determining if there's any obstructions on the ground, if you're, say, laying a cable on the ground. It's important for inspecting the base of anything that has been affixed to the ground and understanding the sedimentation. And so traditionally, this is done with a ship with people on it, and you basically just go back and forth and you do a little grid, and then you start to paint a picture. That can be challenging in many areas. One is when the weather's not cooperating. So we can go out and survey in conditions that are too rough for a boat with people on it. So it extends the window of when you can survey into poorer weather. Another area is, for example, shallow waters. You can't take a boat with people in it in very shallow waters because the draft isn't big enough and there's risk associated with it. And this is especially true in areas like the surf zone where our boat is performing right now. So it opens up the ability to survey this area with an autonomous boat versus much more labor-intensive methods that would involve a diver. The other area is marine life monitoring and marine mammal detection. So, in areas where there are endangered marine mammals, such as the east coast of the US with the North Atlantic right whale, it is even more important to have a very good knowledge of when those marine mammals are in the area, because of course, protecting that endangered population is very important. And that's protecting it from accidents, things like ship strikes, but also protecting it from noise. So during construction of an offshore facility, there's a lot of noise from pile driving and other activities. So there's a lot of requirements around it to ensure that there are no marine mammals in the area. So this is traditionally done usually with ships, people on board looking for whales or listening for whales. With an autonomous boat, you can do that as well, but without the people on board. So we tow a hydrophone behind our boat, which is it's an acoustic array with actually multiple hydrophones, but it's basically like a microphone for the water. And you can listen for those whale vocalizations. You can hear them quite far away because noise travels a long distance in the water, and then you can report that in real time, so you get the detections on when marine mammals have been found. And this is it's a more affordable way of doing it, but once again, it can be deployed in conditions where it might be challenging to put a crewed ship or even an aircraft, which is commonly used for that. Another application is security. So monitoring those offshore assets. You can put cameras, acoustics on a vessel like this that can help with that. And then there's a whole range of oceanographic and meteorological data. So better understanding what the weather is there and a little bit farther out, better understanding the wave conditions or even the ocean currents. You can have a piece of equipment called an ADCP, acoustic Doppler current profiler, that tells you those currents in the vertical water column. You can do things like look for hydrocarbons, so ensuring that there's none in the water and monitoring those levels. And then another element where there's potential is subsea communications. So if you have a sensor on the seabed, it cannot communicate what it is detecting unless it has a connection to the surface. So what is often done is you have a vessel like this that goes above it at the surface, and it has an acoustic modem. So it can use acoustics to pick up that signal from underneath the water, and then it can communicate it by satellite or by radio, or sometimes even by cell to the operator on shore. So it gives you a better picture of what's going on at the surface and below the surface. So in as Aaron spoke about, the 4Ds, dirty, dull, dangerous, and dear, robotics has an application like that. When we compare it in the offshore wind, or on the offshore oil and gas and wind industry, where, often data is collected by ships or moored structures like buoys, or even fiber optic cables, or aircraft. Robots offer a more affordable solution, really at a fraction of the price of some of these other alternatives. They offer a safe solution because you're keeping people on shore instead of in the ocean environment. It's a very non-intrusive solution. It doesn't require anything to be affixed to the seafloor, where it might require, some significant permitting or create other risks such as entanglement for marine mammals. It can be easily redeployed, and it can be launched in a range of conditions. And so that high adaptability, also to measure a range of conditions, to deploy it in different areas, and to deploy it when it might not be possible for another solution to be deployed. So we founded Open Ocean Robotics just over 2 years ago. I had a previous boat company and a maritime company prior to that, but really the goal with Open Ocean Robotics was to help us understand our oceans so that ocean industries can operate more safely and affordably and sustainably, and also so that we can grow our ocean economy. And our boat, Data Explorer, it's about the length of an average kayak and about the weight of an average male. It can be deployed from our control room here in Victoria or in Houston from a harbor, and you can control it from anywhere in the world. So we can control a boat that's just 100 miles away or in the middle of the Pacific Ocean. And you do that using satellite communications mostly, but there's also radio and cellular. It's completely solar powered, so it gets over the energy challenge with robots that Aaron spoke about. So it can collect energy from the sun, meaning it can be out there for months at a time, just being deployed and running off the energy that it has, or else you can deploy it for shorter periods of time with a larger battery storage bank, so that it can run higher power sensors. And then there's a whole range of sensors that you can put on a vessel like this. So you can see and hear the ocean using optical and thermal cameras, as well as a hydrophone. You can measure things in the ocean like hydrocarbons or dissolved oxygen or turbidity or chlorophyll A. You can measure things in the air like air temperature and wind speed and wind direction. So there's a great deal of flexibility in what you can measure and how you can deploy it. So with a vessel like this, there's a few things that I guess make it unique and give it a competitive advantage. One is it's very easy to use, to deploy from a boat ramp or from a ship, and then control by the operator. So it's very much like driving a car. You can make precise turns, you can do a grid pattern, and it can travel in a range of conditions. Because I know what it's like to be out in the ocean and in a big storm. Actually, when we rode across the Atlantic, we got hit by 2 hurricanes. It happened to be the worst hurricane season in all of history. So despite the best planning to avoid storms, it didn't really work out that way. But that's the reality of working on the ocean, is it's unpredictable and you have to be prepared for extreme conditions. And so one of the most important things for us was designing a boat that can endure that. So it is a self-righting boat. It uses a passive righting system that's based on buoyancy, and it can capsize repeatedly and keep on going. So, what our goal was to really open up the possibility for ocean data collection by creating a robust, rugged system to go out there. So the company was founded by myself and my partner, Colin, who has rowed across the Atlantic with me, and we started a previous company. I have quite a bit of experience in the maritime space. I'm currently a director for NATO's Maritime Unmanned Systems Initiative. Colin has a number of world first expeditions that he's accomplished, including several first river descents. And then we have a great group of engineers supporting us and a great team of advisors helping us build this company. And, it certainly is an adventure building a startup company. Since we founded over 2 years ago, we've completed our prototyping. We've worked with early customers to develop our technology. We've raised money through grants and investments, and we've done pilots in several areas. So we're at the stage now where we're showcasing what is possible with technology like this. And I think some of the pilots that we've done also demonstrate the utility of technology like this in the offshore wind industry. We've worked with Vineyard Wind, which is building the first offshore commercial wind farm in the US. We've also worked with NOAA on monitoring against illegal fishing, and the Department of Fisheries and Oceans in Canada for environmental monitoring, as well as the Canadian Coast Guard for seafloor mapping. And along the way, our company and this technology has received global recognition for really its innovative approach, which has included the Solar Impulse label and Cleantech Group's 50 to Watch listing as well. And I just wanted to quickly talk about some of those pilots and maybe how they could connect to the offshore energy sector. So one of the projects we did was participating in the Offshore Wind Challenge, which was an initiative between Vineyard Wind and Greentown Lab for real-time marine life monitoring. So this is during construction and other times, ensuring that they are operating in a safe way. And in particular, they were interested in North Atlantic right whale detection because in Massachusetts and in those areas, that is the habitat of the North Atlantic right whale, and ensuring their safety is very important. So in this case, it was listening for whales. We had a hydrophone on our USV, and we demonstrated the ability to hear these whales from a really long distance away. Another pilot was in security and enforcement. So this was working with several organizations in the US, including NOAA and California Fish and Wildlife. And one of the big challenges in this area is that 30% of fish caught is caught illegally, but it's extremely difficult to patrol those large regions of the ocean, the marine protected areas, because they are big and they are remote. So looking to robotics to overcome that challenge, and vessels like ours and others that can stay out on the ocean for long periods of time. And in this case, once again, acoustics is a tool, but also cameras and AIS detection. And finally, the other one that has relevance is hydrographic surveying, so seafloor mapping. In this case, we worked with the Canadian Coast Guard to create the first fully solar-powered USV with a multi-beam on it. And this enabled surveying in a range of waters, but very importantly, shallow waters, because one of the risks and challenges of shallow waters is that you could run aground, damaging a vessel, but also that it's very dull, because in shallow waters, you have to have very narrow swaths. So the boat is just going back and forth a lot. So being automated really helps overcome those challenges. And I think in conclusion, I just wanted to briefly touch on the potential for the future, the potential robotics and automation has in energy and in offshore energy, and what that can mean for your careers. I think it is an exciting time. There is going to be change, there is going to be adoption, and it opens up a lot of opportunities for careers that might not exist now. And I think that we're going to see a shift to some degree in the skill sets that are required. So taking more people off the ocean, but having them work on shore, really still doing similar things. So skills in robotics, skills in automation, skills in AI are going to be very important. And I think in many ways, this could help grow the ocean economy. So we're going to see more jobs in this area. And actually, the blue economy is predicted to be one of the fastest growing industries, and it will double to 3 trillion by 2030. So thank you very much for having me as a part of this symposium.
That was delightful, Julie, and thank you for giving us a taste of this challenge and this application that you've been working on. So I want to remind you that you can ask questions for Julie or any of the other speakers with that button, UH Energy Ask, and we'll have some question time at the end of our third speaker. So with that, I'd like to invite our third speaker, John Allen, to take over, to turn on your camera and your mic, and he's going to give us another perspective. So we've had this perspective of a large industry, a startup, and now we're going to sort of span that and also show how the universities can couple in that. So take it away, John.
Thanks, Aaron. And Julie, I love the idea of a solar powered, my next car, I want to be solar powered and be off the grid. So we'll work on that one, I think. That's wonderful. I don't know why we don't do that. Yeah, so welcome everybody. Aaron's correct. I think we're going to start more at the research end, but also I'm going to talk about the Subsea Systems Institute, what it is if you're not familiar, and what our mission is and what we're trying to do. And it's a bit different, I think, than conventional research in a bit, in that we really are focused on delivering to industry. So we're looking at the full sort of cycle. We will be doing research to uncover new ideas because we need to, but we are looking at how we get to deliver those technologies to market. So consequently, we've got an industry board, which we work very closely with on mapping what, like Mauricio, on what the needs are, what the industry needs. So just as a bit of background, it's a collaboration between the University of Houston, Rice University, and NASA. It's funded by the Restore Act. You saw some pictures of Macondo there, Aaron. That's sort of where the pot of money came from to fund this program. And we're looking at how to change the industry from a safety, efficiency point of view, and what the industry needs. We're particularly focused on the Gulf of Mexico because that's where the funding came from. but we're really focused on remote applications, and some of the things we'll talk about is why that's relevant compared to local applications like robots in factories. So we're different. We're looking at remote applications and the subsequent technologies that we might need to support that. So next slide, please. There is a delay there, so you can see the main players there. You saw Ramadan and Stephanie there, so I think they're both on this call. So if you've got questions for them, they're here. Just on the sort of, as I mentioned, it's funded by the Restore Act, so we're funded, but we've got two programs. We've got a technology research program that's been running for a while now. We've actually completed our first 4 years, and we're just starting our next 4 years, and the first year of that 4-year program. But we have, as I mentioned, we have a challenge, and I've put Mauricio on notice here to think about it. He thinks about it daily, though. Is what technologies should we be developing? That's what we've got to define, and we've got roadmaps. We'll talk about that in a minute, and how can those technologies be deployed? So Mauricio touched on a whole load of those things and what the challenges are. And I've got a wheel in there as well, and I've got an example in a bit. So some technology we'll look at. Some technologies won't get deployed, right? So we just need to be aware of those and why that is, and see if we can minimize the developing those technologies, or at least stop developing those technologies when we know that. That's a big challenge. What are the barriers? And I'm sure we're going to get into that. Hopefully some of your questions will ask about that. I'll finish with a question, and what stops things being adopted. And there's lots of examples of things that we thought were wonderful. Technology-wise, they're fantastic, but end up not getting adopted. We need to understand that better. And then we really want to, because we're research, so we're TRL, if you're familiar with that term, technology readiness level, we're TRL 3, which is at the research end. Deployment ends up at somewhere like technology, TRL 7. So we're really saying, how can we shorten that cycle, going from 3, or even earlier when we have innovative ideas, how can we shorten that whole delivery system? And then skill sets. We're going to talk about what skill sets we need to deliver. And Julie mentioned that, so changing skill sets. So we're looking at changing skill sets to deliver what we're doing now. And then we're doing some prediction, where we are in the future, where we're going, and what skill sets are needed for that. Touch on a bit more of that in a minute. As I mentioned, roadmap. So we're working I'm from industry, although I did run various research groups in industry. I'm not from university. We're working very closely with industry to roadmap what the use cases are, what the needs are, and how we can get there. And then we're looking at, we mentioned oil and gas, we're looking at oil and gas, but also any forms of offshore energy, alternative energy, ocean energy, including hydrogen. Next slide, please. Okay, so as I mentioned, there's 2 programs. One is the technology program. I'm going to talk a bit more about that in a minute, the COE for research programs. And then there's a workforce and economic development program. That workforce program, we've just been approved. I had a detailed slide on areas of development in that area, which I've taken out, and I'm going to make the guys on the call, you guys on the call, work for this by thoughts and ideas and questions on predicting the sort of like the sets of skills you're going to need for the future. And I'll take you through what we think about what's coming, and then we need to work on those skill sets. So we've got an advisory committee here. We're looking at development and training and various certifications, and we're looking at a phased approach. So we're looking at upskilling for new technologies. Julie mentioned we won't have people on boats. We're going to talk a bit more about having people offshore or not. We won't have people on boats, but there'll be a whole lot of skill sets that we need to deploy these robotic solutions instead. So we're looking at that right now, as looking at upskilling for new technologies, taking people with skill sets and then upskilling those skill sets so they can work with the new technologies. And then we're looking forwards into like a carbon-free oil and gas, and then onto renewables, and a much more complicated set of skills on how you integrate all these systems. Again, we're going to have an advisory committee. We're drawing from industry, from research, and from people organizations. So what sort of skill sets are needed, and how we get those in place. We're moving over to the research areas. we've got a whole load of programs that we're focusing on electrification. So I guess we're following the car model: electrification, robotics, and digitalization. Mauricio, I think, is really interested, mentioned on sensors and digitalization, which is a key thing, but how do we deploy that using robotics will be a subject as well. Just as a little mention, we're obviously NASA's part of our group, and we're looking at a pretty cool training program with NASA on robotics. So generally, electrification, robotics, digitalization, and then we're talking specifically now about robotics. For the next slide, please. Okay, so I think Julie mentioned lots of underwater robots. My background is underwater robots, so I can talk forever about underwater robots. We're getting Aaron very much involved in underwater technology, so he's very enthusiastic. And then we move on to how we deploy robots not underwater. And I guess there's differences, right? In underwater, you can fly things. So my origins, which we'll touch on in a minute, were sort of from the aviation and sort of defense side for flying things. Underwater, we can fly robots underwater, because we can get neutral buoyancy or do things with buoyancy and fly them around. So when I say underwater, looking at Mauricio's diagram, he had lots of tanks there full of liquids and oil and chemicals as well. So I mean under liquids generally, but the big theme for now has been oceans and underwater. If I just start on the left here, this program we did at Rice on innovation of flying vessels. So what sort of propulsion do we have, and can we have innovations in how we thrust, looking at a Hummingbird, how we can drive these things to have much better positioning on the drive side, and maneuverability. And the point of this is to deploy sensors very accurately to determine, maybe in this case, integrity of systems. Because we can fly these things, we can make use of the Neutral Buoyancy Lab at NASA, which is a massive swimming pool. Aaron's got a great video of his team working down there with music. This one's just without music, and it shows doing tests with this vehicle on a sort of test piece on the bottom of the Neutral Buoyancy Lab, showing cracks, corrosion, and issues like that, integrity issues, and how we can actually position on those very accurately enough to take readings and detect those flaws. We're also looking at some innovations in buoyancy to make that even more practical and to enhance power management. Aaron's picture on running out of power is always in our minds when we've got particularly autonomous vehicles, because they're driven by the power source that you've got and until you charge it. Unless we've got a boat on the surface that can charge using solar, which we haven't figured out how to do that underwater yet. There are ways we can do things to improve endurance, but it's then about power management. And the next thing is that one of Aaron's, in fact, which is looking at the application. So electromagnetics underwater are a problem because the electric bit in saltwater goes away pretty quickly. So we're looking at projecting magnetic fields underwater and what we can do with that. It's an innovation because historically, as Julie said, we use a lot of underwater acoustics that are much more suited to underwater applications. We're looking at magnetics, one for anti-collision. So this shows Aaron having two vehicles in the Neutral Buoyancy Lab pool, showing how they can maneuver without colliding with each other by relating to each other. And clearly this applies to two and a huge number. So it talks to swarms. You can't manage a swarm unless you know where each part of the swarm is, and this talks to that technology. And we're looking at using this for short distance communications, as well as avoiding collision with structures as well as each other. So innovation technology that's not been applied. And we are looking at other technologies like acoustics, but they're quite well developed in this application. We're looking at if there are any novel applications we can use. So remember, we're research, so we're looking at TRL3. We're not trying to reinvent the wheel. If we go to the right-hand side here, and I have to move my picture because it's in the way, we're on land. And I guess the difference in land is you can't fly, so you have to, I guess, walk. And we've looked at various ways of moving things around. So this top right-hand corner shows a wheeled vehicle. We actually developed a mini Mars rover, and also bottom shows a tracked vehicle, and we're looking at legged vehicles, 2 legs, 4 legs, and 8 legs. So there's various ways of moving things around if you're on land and you've got gravity. And then you have all sorts of interesting things like obstacles, like stairs and lips and things in the way. And if you go to NASA, they've spent a lot of money trying to get their robots to walk around on bricks and obstacles on the floor. So it's a challenge. which humans deal with, and we're trying to figure out how to move things around. Now, of course, this is on facilities where you have obstacles. The facilities of the future, greenfields as we call them, we can design to be much more friendly to robots. But you know, we still have to move robots around. So the focus has been on technology, and Marissa mentioned this quite a bit, on sensing technology and how we can apply smart sensors. What we're looking at here on the top right is a robot that can use stereo cameras and pattern recognition to locate itself on things. So it has to recognize, in this case, it's a flange. Is it a flange? What does the flange look like? And where do we want to position ourselves on the flange? So we have to make the robots smart of what they're trying to identify and work with, and then applying smart sort of sensor systems to detect issues like flaws in materials, or in this case, how tightly a flange is bolted. And I'll talk about that in a bit more detail. Bottom right-hand corner shows taking some of that smart sensor technology and applying it to the NASA Valkyrie robot as a smart glove. So it can actually do more things with its fingers than it could previously do. Next slide, please. Okay, so this is for you know, I'm not going to talk through this detailed list, but it is a detailed list of what we got from mapping out the issues associated with putting robots in remote locations, and also what technologies are needed and involved in that challenge, and sort of a map of where what things we're looking at. So if you read down the right hand side, you can read it faster than I can talk through it, and I'm not going to talk through it. But if you see things there that pique your interest, or you've got questions about, this is really for you to think about questions on some of these things that we're looking at. To summarize though, from the mapping process, communications to and between robots is a challenge for remote applications. Julie talked about using various ways of communicating. What we find for instance, offshore, is that they are great, but we're limited on bandwidth. And sometimes, as we know, they don't work. So you have to design robots that are doing things to work with bandwidth, and also to figure out what they do when they don't have those communications. Clearly, in some cases, you've got communications, but it's low bandwidth. And so you can talk to things, but you can't, for instance, get a lot of data because the bandwidth's not there. So we have to look at all of those different applications and what technologies we might want to use to manage that. And of course, if you look at the top, obviously autonomy doesn't need communications. And so in some respect, the NASA, if we look at the NASA Mars robotics, they're going to have robots on Mars. If we're going to communicate with them from here, it's going to have a big delay and a fairly narrow bandwidth. So you're going to just be giving instructions. You're not really going to be monitoring what robots are doing or telling them what to do. They'll be doing it on their own. So as we move towards that autonomy, we're going to need various types of communications, how we use those. Underwater is pretty well advanced. I mean, we've been putting robots in deep water for a long time for various things. I mentioned military, but also for oil and gas. They're at 12,000 feet in the ocean or more. Oceanographically, I didn't mention I worked at an oceanographic institute, so we put things in the ocean, deep ocean, so 5 miles or more. So we've been doing this for a long time, and it's well advanced because we had to, because we couldn't put people there. We're really, it's fairly well advanced in using tools as well, because we use robots underwater to do tooling things. So we've been looking at the underwater application, what things we can do in there that aren't being done, and particularly the autonomous thing is big. You know, we're looking at autonomy now much more than they had before, and it's the new area for us. Land and looking at platforms. Obviously, I mentioned getting around. We had a project to get through doors, which robots couldn't get through doors. We figured out how to get through doors, and then watertight doors have got a lip, so we then got to get over the lip. So there's some things there that are fairly easier for a human to do, but we didn't have robots to do that. As I mentioned, there's plenty of opportunity in smart sensors, smart tools, application of artificial intelligence, learning, and deep learning, and that's what we're looking at. We can apply those to land platform robots, but but we can also apply those to subsea as that technology evolves and it's got new technologies are available to us. The big question here is, can we do better than people do? It's dirty, as you know, Aaron said, but it's also fairly risky. So people go offshore, but it's something you have to be really careful with. It's quite a risky environment. So we can make it safer. Robots can maybe have less errors because people get tired, they get distracted, they get bored, right? And they get stressed when things happen. So they make decisions that aren't necessarily great decisions. So automation for sure, but applying robots, we're looking at, can we do things better? And Mauricio, I guess, you know, robots, we can make really small robots. Aaron's working with really tiny robots. We can put them in places humans can't go. We can make very thin robots. We can make robots that change shape. So all of those things humans can't do. So when we're looking at the business case, can we do things with robots we just can't do with humans? Just if you'll scan down the side there, we're looking at, if you look at sensing, we're looking at acoustics, shear waves as mentioned there, fiber optics, Julie mentioned that, fiber optics for sensing as well, electromagnetics, we mentioned that. And so we're looking at a whole lot of physics issues on applying sensing and transmission media and what's not been done and what we can do. So I'll leave you to scan that page and think of questions and go to the next page, please. All right, so back to our challenge. So as we mentioned, how do we, I'm moving towards Aaron, my first question to get people started, and then we can get a whole load more. But I've got the first question just from me is, what are the barriers? How can we shorten it? And then what skill sets? That's what we're looking at. That's our challenge. And if you wouldn't mind, I'd like to give you an example that I experienced. So as Aaron mentioned, I actually worked in GC Marconi Avionics. I was the chief engineer. I was a very young chief engineer, responsible for offshore energy and underwater vehicles. And we had a wealth of technologies from aviation, from fly-by-wire. We moved away from pilots piloting to as airplanes got very complex. So we moved to fly-by-wire, which is electrical control of aircraft, to fly-by-light, which is even more data, and subsequently to unmanned drone vehicles. And we applied that technology to underwater vehicles. So aviation automation was driven in part by aircraft being complex and unflyable. In fact, with fighter airplanes, you couldn't maneuver those. They're non-aerodynamic. And in part for the need for the humans to do other things rather than spend his time trying to fly or her time trying to fly the aircraft. So the vehicle is ostensibly autonomous and the pilot was a passenger. So you've all heard of autopilot. We had other technologies like head-up displays, stereo vision viewing, which I've talked about on our technology development program for human interaction, artificial intelligence and learning. And next slide, please. The reason why this is particularly interesting, because we've talked about these technologies already. Next slide, please. Yes, this was all done in the early 80s. Let me just next slide, please. We had a lot of technology some time ago. So where are we now? So modern underwater vehicles, Julie mentioned this, modern underwater vehicles are moving slowly towards remote support. So we sit in an office now in Houston and we can control offshore vehicles offshore. So there's a change of roles there. People are learning how to do that. There's an increasing use of autonomy. We automate a lot of the processes, all fairly recent, all in the last 5 years. We are looking at putting, as Mauricio said, putting robots on offshore installations. We're growing in traction in that area, and this requires a level of autonomy and an adoption of these technologies similar to the NASA challenge. So next slide, please. And I'm getting the thumbs up side here, so I know I'm out of time, but this is the last slide. So that technology we developed was 40 years ago. We didn't have comprehensive GPS, so we didn't actually have microchips. Certainly we didn't have microcomputers or smartphones. Technology is advancing really quickly. So the question is, why is this taking so long? And we need to understand more about that and how we can get these things deployed. We have technology. So it's really the challenge is deployment. And that's leading to question and answer. Thanks, Aaron.
That was great, John. And it really gave us a high level view of it and some of the directions we're going. Now we're going to switch over to the question time, so you can still submit questions. But our first question is from Jewel, and it's for Mauricio. And he's asking, I think they're really concerned about where the jobs are going to go. If this guy's going to take my job, then what other jobs are now available? And his question in particular is, are there options, are there jobs for drone pilots? Is that a good direction to be going, both for inspection, for other tasks? Is that something that you hire at Chevron or outside people? Where's the career path there?
Yeah, in most cases, we prefer to hire companies to do this work for us. Our core business is to get oil from the ground and make products. Any other activities that include inspections, maintenance, and other support activities, we prefer to hire them outside. In the case of drone, we have a mixed program right now where most of the work we still do it with external companies, but in certain facilities we own a fleet of drones that we operate internally. And the reason is that in many cases, we may need information immediately, right? So we cannot just pick up the phone and call the company that is a few miles away, hoping they have people and equipment available to be there in 20 minutes, right? So the opportunities for robotics, including aerial systems, is incredibly large. This area is going to keep continue evolving. We are now exploring not only flying systems for visual, but also with tools. For instance, we are now able to paint walls. We're able to do ultrasonic thickness inspections, electromagnetic inspections, and some other activities just with this flying platform. So it's just the beginning. Plenty of opportunities out there.
Thank you. And to flip that to Julie, where are the jobs going to be with these smaller robots? Is the jobs in the engineering? Is it in being the pilots and the day-to-day service? Where are the opportunities there?
Yeah, I think it's a little bit of everything. So there's definitely going to be a lot of engineering still going on as people continue to advance the capabilities of these robots. So, continued improvements in autonomy, so more onshore processing so that we can overcome some of the challenges of limited bandwidth and limited communication. But of course, that is all changing as well as we look at the possibility of low Earth orbit satellites and how that could expand communication from the middle of the ocean. And then operating drones is definitely an important future role as well. We're already seeing it in some companies that are deploying robots as a service in the ocean industry. For example, X-Ocean does that for hydrographic surveying, and they've recently gone on a hiring spree, hiring dozens of operators for these USVs. And then I think computer analytics and data analytics is another big one. So we're going to see AI play an increasingly important role. So for example, for us, we're using machine learning for visual identification of vessels, of marine mammals. So I'd say those are some of the areas where we'll see future jobs.
Thank you for that, Julie. Mauricio, we've got a question for you that's asking, as robots are becoming more prevalent, how is your company protecting robots from cyber attacks? Have there been any such incidents, especially in these large companies?
That is definitely an area of concern. We are trying to do the best we can with the tools that are available. We have a large group of IT looking into just the security of these processes. We have our own cloud, and there is always this interface where advanced systems may require operation on the cloud, and then how do we share that information to our cloud with all these security that we need to maintain. There are no easy solutions. I think that's an area that still is in exploration. We haven't had any incidents, but we are definitely being careful about that. So it's an area where we need to be careful. That may be a roadblock. Just going back to some of the comments from John, all these things are important. And when we present a proposal to do work that we're going to do in a different way, all this is part of that decision. If we cannot show we're going to be safe on how we manipulate the data and the images and information we create, that may be a barrier that we need to resolve before we go into adoption.
Delightful. Now I've got a question for all three. We're going to start from the last speaker forward, but I want you to tell us a story about a game-changing technology during your career that's affected your spot of the energy industry. So what's a game changer that you've experienced in your career?
Well, yes. So, I mean, we were working on analog computers, right, when I started. So I mean, there's been a huge, the NASA story, right? The computer on the space, on the original NASA thing was, less powerful than the iPhone. So that computer power, it's part of my career question, right? The computer power, we did a lot of things with very limited computer power. And that has changed so dramatically. And then GPS was really limited. And as Julie just said, I have no idea how many satellites we're going to have up there. We're going to have communications out the wazoo. So that's just huge. That whole scaling, integrated. So everything's much smaller and much more powerful, which allows you to do a phenomenal amount of things, which we just didn't have any of that. So from a technology perspective, that's just a huge change.
Yeah, I think for me and for us at Open Ocean Robotics, we wouldn't have been able to form this company 5 years ago. Our technology is dependent on innovations in other areas. So advances in lithium ion battery storage, advances in computing, advances in open source software, and advances in sensors. So they're becoming smaller and more power efficient. So all of that really comes together to enable technology like ours, which is dependent on maximizing the use of the limited energy that we have. It's dependent on advances in communication and computing power. So I think technology has made a big impact, and it will continue to make a big impact as we move forward in this industry.
For us, is in the area of inspection, we have two main components, the sensors and the delivery platforms. We have two basic technologies we use to look into the materials, which is radiography and ultrasonics, which are basically the same principles you will use in medicine. The evolution of these technologies on the industrial side has been exponential. Over the last few years, the way we can look into the materials and detect flaws and damages is increasing dramatically. That intersection with new delivery platforms, either with remotely operated devices or autonomous systems, makes this junction very, very interesting. We are still in that process of trying to make that match between what we need and what is available. We are expecting still to see a lot more progress on both sides, right? On sensor development, and which includes also the processing of the information and the AI associated tools, and also on robotic platforms, which includes all the mechatronics and all the physical movement, including force and dexterity and all these other capabilities that we need.
So we've heard that computing power is a huge one, batteries, sensors, software, analytics, and then you pointed up on some of your wish lists that you want for the future. Julie, do you have a wish list as well for the engineers out here to develop?
Yeah, absolutely. So, I mean, I think one of the things we're most excited about is low Earth orbit satellites and what that will mean for communication from the middle of the ocean, because bandwidth is such a big issue. And so instead of, doing the processing on board, we can, do it on the cloud. We can have access to so much more information. We can stream video and acoustics. So that's one of the areas that I'm really excited about.
John, it might not be fair for you to pick out one of your list of things that you really want to see.
No, I mean, I can ask the question instead, though, can I? I mean,
yes, you can.
My problem is, and I worry about this, right, is from an adoption perspective, is things are changing so quickly. I'm just concerned people wait, right? I mean, people can see technology changing, so they would just wait. So rather than develop a solution that's based on what we've got now from a communications perspective, as I said, Julie, I'm looking at what's going on there and saying, I'll just wait, because that problem just may go away. So my sort of concern is that how do we react and deliver stuff when technology is changing so fast? Batteries, I mean, everything is changing so fast. So how do you lock in something? And I would do a lot of work with like API and standardization. I just don't know. And I'm on a call this morning and they're saying we want to standardize. And I go, sure, but then it'll be different tomorrow.
Yeah. If I can add one thing, that merge in robotics between dexterity and the force we can apply. If we want to use machines to replace what we are currently doing, we need to understand what is that we are doing with our hands and with people. And I mean, just holding a pen and a cup at the same time and trying not to spill when I change this to another hand, a robotic device right now cannot do that, right? There are a lot of activities that we humans take for granted, but when you try to mechanize that and to replace some of these activities, it becomes very challenging. The fact that there is a screw or there is a bolt, I mean, we'll just pick the tool and do it, but the robots don't necessarily have that capability of adapting to those environments. As John was saying in one of his comments, we have like two environments. The one where we're living in, which we call the brownfields, which is the operating platforms and refineries, and the design that is coming in the future, which we call the greenfields. Doesn't matter what we do, the brownfields are still there and they're going to be there for many, many years. So we need to develop technologies that are going to have to deal with equipment and machinery that was designed to be operated and maintained and inspected by people. And to me, that is a great challenge of trying to understand what is this need and where that technology may intersect to find a good solution.
We've got a question from one of our listeners who's asking, we've seen all these advances. What are the things that's holding it back that you've seen in your careers, especially over the last few years? Is it technological limitations that's preventing things from being adopted? Is it regulatory? I don't remember what the third one was. Yeah, but what's holding it back? Why aren't we seeing our new robots?
I can hop in there. I think it's market adoption. So I think the technology is there. We've got some amazing robots. Yeah, there are some challenges in the regulatory environment. We see that in our space. So, in surface vehicles, obviously they don't have a person on board, so they can't abide by the same rules and regulation for collision avoidance. So here in Canada, we're just putting in draft policy right now. And basically we were not allowed to operate on the water for a while until we got an exemption. And so there will be some challenges there, but ultimately it's the customer, and you got to convince them to be able to, adopt this new technology, that it's going to serve their needs, that it's going to have advantages. They have a solution right now. So why are they going to, take that away and replace it with something else where there's a level of uncertainty? So I think for us in the industry, we need to find those early adopters, and we need to work with them to show them that we can provide a better solution. It's safer, it's more affordable, it's more environmentally sustainable, and then kind of bridge that gap, that chasm to more widespread adoption.
Go ahead, John.
I was waiting for you, Mauricio. I mean, just luckily for us, of course, we're government funded, so we're actually fairly tied into the government initiatives. So from a regulatory, we're well positioned. That's why I mentioned some fundamentals. We're trying to take an offshore oil rig. If we don't have people that travel, go on helicopter, go to rigs, live that life, it's all risky. I don't think we're going to have a challenge in doing that, because it's all for really good reasons. And we've got authorization to find really good jobs for those people as well. So I think we're hitting all the bases. Yeah, I think it's just a matter of adoption. And I think Mauricio said, I want a robot that can work on a brownfield. It's the NASA thing, right? We're working with the MAN program, so they want robots that are going to work in an environment where people are as well. We just need to demonstrate that. I do think that we're looking at some smart technology that can do things that humans can't. So rather than your example, Mauricio, of the pen and the cup and the things like that, I'm not going to ask the robot to do that. But what I will do is ask him to maybe operate a valve, and then at the same time listen to the valve and do diagnostic as we're doing it. So I think they can do tasks where humans just not, they go get tools and instruments and do it. But I'm going to have a robot that can do all that all at the same time and be smarter. So I think our pitch will be, from a business case, is get people out of harm's way. I'm not going to have a regulatory issue with that, I don't think, and then get robots to do things that are better.
For us, it's all about value, right? We need to really understand what change means, and what are we trying to do, and what the solution that we're going to try to adopt will cost to the company. Your example of closing the valve, yeah, I'm sure we can closing a valve, but we don't normally just close a valve. We close the valve looking at a gauge, and we close the valve just a little by little until that gauge gets to a certain level, and then we go to the radio and we talk to the other operator to see if the level on the other tank is already in the side on the right place, so I can continue open this valve, right? That is the reality. So we are taking the first steps, and we need a solution to open the valve, but now we need also a solution to interface with a camera and getting these smart systems to understand what other parts of the process are being affected by you manipulating that valve. And that integration of all these sensors and manipulation and the operational aspect needs to be part of it. If I go to management in my company and I bring a solution, I need to clearly understand what are we paying for it, and what are the risks, and what is the quality of the information we're collecting, and whatever I have to present needs to be able to satisfy those 3 points. We are, of course, willing to work in part of the development by adopting partial solutions, as long as we have a clear vision of where are we going. On that example of low temperature and high temperature, it's the same situation. We can develop a tool that can open a valve, as long as we have a clear understanding that that is not the solution that we're looking for, is the full understanding of that process and how we manipulate that valve as part of that environment. That is a slow process, but to me, that is the only way that we're going to make progress. Until we don't understand what are the capabilities of these machines, and we cannot communicate to you and to the developers and to the universities, what does it mean to do what we do and what other things, I don't know, we may need to build the scaffold to reach that valve, right? So, you know, yeah, there are no climbing scaffold robots yet. So we may need to have something flying to get up there. Yeah, but now how can you manipulate the valve when you are flying? I mean, these are some of these basic things that that we need to work together. And that's why I think it's so important to have these type of forums where we can really learn from each other and advance this way of making small steps with a clear vision to the future.
Thank you. I heard that we need to find those adopters, and we need to do that by proving the viability and showing the value add. And mainly, it does come back down to dealing with people. It's got to be part of that solution. So we're going to switch over to Ramanan, who's going to give us some closing statements. Thank you.
Actually, I wanted to ask Julie and John and Mauricio if they had any closing remarks, and then we'll wrap up the symposium. So Julie, you have any closing thoughts?
Sure. Yes, I think, you know, there's a lot of potential for robotics in the energy industry. And, you know, it's up to us to all work together to see how we can demonstrate value and provide the solutions that people like Mauricio are looking for. So, you know, I think forums like this are just a great way to do that. So thank you.
Thanks, Julie. John?
Yeah, Mauricio just nailed it. I think he's what he outlined there was, I mean, if you look at our thing, we were talking about like integration, you know, and then what do people do? Well, you know, use cases. So somebody in Chevron knows all those things you just described. We take that expertise and we learn the machines. So, and then we take all the data that's around everywhere that relates to that task, and we integrate. And I think they're just the big issues that we have to, and they're you know, I think that's exactly right. And I mean, otherwise they're going to be in a factory doing repetitive single tasks, which is, we've done that one. We've moved on from that. So now we're trying to do much more complicated things. And I think that's what Mauricio said is exactly what we need to do.
Correct.
And Mauricio?
Yeah, thank you. I just want to thank again the opportunity of sharing our thoughts, and hopefully, you know, the next generation of engineers have these ideas very clear when you go out to start your new company. You know, the young companies out there, let's talk, let's communicate, let's try to learn. We don't know everything for sure. We need to keep this open mind of maintaining a clear communication to explain what are our needs and to find that perfect intersection with technology that we can use.
Thanks, Mauricio. That's just absolutely sage advice. But you know, one thing that I must say, and I just hope that we have, as we move forward, there's a much larger representation of women in robotics and automation and in engineering, because I think you know, just the kinds of things that Julie and her company have been doing, just eye-opening for all of us in terms of what can be done. So you know, if there are young women listening to this, I hope that they take this on and take on the challenge to build on the kinds of things that are going on. But I want to thank our moderator, Aaron Becker, for a fantastic job. Our speakers, John, Mauricio, and most importantly, Julie, for participating and being such a wonderful set of panelists on this important topic. We certainly hope that you'll come back and share with you your insights into the future, and about robotics and automation. I want to thank you all for joining us for this symposium and for the series. We will be back next year, 2021, 2022, and we hope to be back live. And so next time we do this, we'll hopefully have some robots walking around and doing things in live audience. And that's the way I think, especially some of these ideas about robotics automation just become much more explicit and obvious when we can have some show and tell. So we'd love to have you all come back on campus and spend some time with us and participate in the next year's symposium series. And for topics and suggestions, we'd love to hear from you. We'd love to hear from you as to what you think are critical issues that we should be covering. And before I close, I want to thank the UH Energy staff for doing a fantastic job to put this symposium together. And again, thanks to our speakers and moderator for joining us today. Thank you all, and wish you well.
Thank you.
Thank you.